Organic salt. Oh, I don't think that was supposed to happen.
Hi, I'm Tyler Fultz. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry. From engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Today we're going to be looking at a video by styropyro. That's an awesome name, by the way. Where he's going to be testing some insane old-timey chemistry recipes, including one for a uranium crayon. Let's take a look.
I've pulled a ton of awesome stuff out of trash cans over the years, but my favorite find is definitely this chemical formulary book from 1933. I mean, there's just so many brilliant recipes inside, from things like soaps and cosmetics to explosives and medications. This thing would have been a gold mine to a nerd living in the 30s. Now, if you've seen any of my previous videos in this book, you'll know there's some just absolutely insane recipes in here too. So of course, those will be the ones we'll be testing today. Now I know what you're thinking. Why on earth am I making a part 3 of this series when I was nearly banned for the first 2 videos? Well, after chatting with YouTube a bit, it seems they didn't like my use of cannons, which I guess makes sense, so no more cannons. Something I should have mentioned last time is that I'm literally a chemist. I have the degree, I've worked in a lab, I've even taught it. And yes, the experiments you're about to see are extremely dangerous. However, I am more than qualified to do them in a safe and controlled manner, and no, you should not attempt them because you'd probably get killed. I mean, there's a lot of reasons why I do this stuff. I mean, yeah, it's fun, but I think that there's a lot to learn from the historic aspects of chemistry, and I also want students out there to see that science is a lot cooler than just filling out worksheets. Anyway, let's see how much further I can get through this book without violating the Geneva Convention.
Looks like an old cookbook.
Oh yeah, I'll be testing recipes from a bunch of volumes this time, not just the first one. Have you ever thought that crayons just aren't bright enough? Well, it turns out making a fluorescent crayon is actually pretty easy. All you need are some uranium salts. Okay, but seriously, uranium in a crayon? What were they thinking? This is one of the worst ideas I've ever heard of. I can't wait to try it out. In this recipe, I'll be using uranyl nitrate as the uranium salt.
Okay.
Uranol.
Oh my.
Now, uranium salts are radioactive.
Wow.
But what really makes them...
So something with uranium that actually glows green. That's, you know what? I gotta hand it to you on that one. I've never worked with anything with uranium that looked like this. Here's what I'm used to. Uranium by itself is just any old piece of metal. And uranium oxide in fuel pellets looks like that. That's the uranium I know. But hey, maybe onto something with some green salts, but that's not what it looks like normally, at least from what I'm used to.
Is their chemical toxicity. Uranium is a heavy metal after all.
True.
On the flip side, many uranium salts are absolutely gorgeous, strongly fluorescent in some of the most beautiful chemical compounds out there. It's quite unfair how something that looks so yummy is actually so toxic. As for the crayon, I ground up the calcium carbonate with the plaster, dissolved the uranyl nitrate in water, and then mixed them together.
Just looks cool.
The resultant mix isn't as fluorescent as it results in a uranyl carbonate precipitate, but without the calcium carbonate, the crayons would be too hard to draw with. I put the paste in a syringe to act as a mold, and let it harden for a few days. Here is the finished uranium crayon. It's really more of a chalk, which means it's prone to making toxic dust as you use it. It does glow nicely under UV light, though.
A lot of things do glow green under UV light, including uranium. Another example would be opals, which are normally a more bluish violet color, also glow green. But yeah, that's pretty cool looking.
Yeah, it's actually pretty hard to draw with, and it is pretty crumbly as well. Toxicity aside, it does look pretty neat under UV. Still though, the coolness to danger ratio isn't quite worth it in my opinion. The rest.
So yeah, the big hazard with uranium is, so it's an alpha source, an alpha emitter. The radiation part won't even penetrate the skin, but you don't want to eat it, so keep it away from the kids that like to eat chalk. That's where you really don't want to take alpha particles internally. But a lot of the scary part that most people associate with uranium as far as dose isn't uranium directly. It's actually the fission products associated with the spent fuel that give you all those gammas, which will go straight through you if you were to be right next to one. So that's those are the main hazards, are the things that uranium gets split into after it's been used in a nuclear power plant.
He said that anthracene could be used instead of the uranium, so I made some crayons based on anthracene as well. These actually glowed brighter and with a blue glow instead of green. These anthracene crayons are significantly less toxic than the uranium ones as well, which is an added benefit. This one's just in time for the never-ending coof season.
Yeah.
It's a sore throat remedy. Now, the ingredients in here look pretty sketchy,
it doesn't have uranium.
so I guess I'm just gonna have to make some and see what it does. I'm not sure what the function of any of these ingredients is, honestly. And in fact, the recipe is quite toxic. Now, you'd think that mixing a strong Lewis acid with a potent oxidizer and an organic salt... Oh, I don't think that was supposed to happen. Maybe those beautiful flames are supposed to distract you from your sore throat.
Or it'll burn a hole in your throat. Hey, it's not sore anymore. It's all cauterized.
The recipe called for a tincture.
Wow.
I figured it meant making a tincture of all that stuff. But in hindsight, it probably meant
so
using
crazy.
a ferric chloride tincture as one of the ingredients. That would make more sense, because tinctures of ferric chloride were used in medicine a long time ago, and it would also keep the iron dosages below lethal levels. Now, this autoignition reaction is actually quite interesting. The sheer act of dissolving the anhydrous ferric chloride in ethanol does release a substantial amount of heat, and it boils nearly as soon as it's mixed. Even so, I don't think that's the only factor for flames here. Ferric chloride is a strong Lewis acid, and it wouldn't surprise me if it's generating chloric acid on solvation with the chlorate. This compound reacts violently with organic compounds, and all the little explosions going on in there make me think that chloric acid is playing a role. I've mixed up a new batch of this stuff.
I like that he's got the gloves, but he's not wearing long sleeves at all. I don't know what other type of PPE he has, if he's wearing goggles or other stuff, but it's like, wow. Most chemists that I've worked with in the nuclear plant, for one, they do a lot of these mixtures usually with a partner to also act as a bit of a safety watch. And I will say right now, I've never seen them do anything that crazy that involves stuff combusting just like that, or anything, not uranium salts or any. It's usually some fairly mild, like water chemistry type stuff, getting samples. They do work with some acids and some caustic, but there's not a whole lot of creativity, for lack of a better word. Everything's from strict procedural use, mostly known stuff that you're doing to adjust, say, the water's pH, to adjust how much boric acid is, say, in the primary part of the reactor coolant system. What's interesting is, so boric acid is another way of controlling reactor power, actually, because the boron absorbs neutrons, and it actually absorbs neutrons at a greater rate than uranium from causing fission. So think of it as a liquid form of control rods, is another way of looking at boric acid. It's another means of reactivity control, at least in the pressurized water reactor that I worked at. But yeah, they would be using more PPE, and they would be doing this job in pairs. I don't know if this guy also has another person working in the lab with him that's just not showing up on the camera yet, but it's interesting to see this sort of stuff.
First diluting the ferric chloride in water, and then adding the other chemicals. Now, if the first reaction wasn't enough to dissuade using it as medicine, I better stick in some aluminum foil in there and see what it does.
See what it does.
Wow.
There you go.
Not only is this stuff toxic and a fire hazard, it's also highly corrosive. Smooth. If you're an American with asthma, you probably have to pay a lot for inhalers. So instead, consider this homeopathic alternative,
Wild mint.
asthma relief cigarette.
Corn silk.
I bet your lungs feel amazing after one of these. I'm kidding, this is a horrible idea. This is a recipe for magnetizable fluid. Now, honestly, I don't see this working that well. I'll take any excuse to play with mercury. Mercury.
Dude.
Yet again, it's unfair that something so beautiful has to be so toxic.
Yes.
Now, to be honest, the liquid metal itself is actually quite inert, but it does evaporate enough to be a problem.
Very low
if there's
viscosity.
a spill. Now, the only thing more toxic than the mercury in this formula is the volumetric measurements of solid powders. Gross. The powders don't seem to dissolve at all, but that's probably intentional. Check out what happens when I bring a magnet near it. There seems to be a distance and corresponding field strength where the effect is most dramatic. Here you can see the field lines actually quite well, but when the magnet gets too close, it just bunches up the iron powder there. This is actually a neat effect, really, because a strong magnet makes the liquid act like a switch between dull and shiny. Don't you hate it how easy it is to get severe burns when playing with fire? Well, lucky for you, here's a nice recipe for cold fire. Now, according to the book, this stuff can be applied to the skin and hair without causing injury. Now, there's a lot to unravel with this one. Cold fire? How's that even possible? Also,
it's like dehydrated water.
Isn't that the stuff that got banned from nearly everything because it causes cancer, it destroys the ozone layer, and it's extremely toxic to the liver? Well, yes it is. So it does seem a bit sketchy to, rub this stuff all over your body and light it on fire. But even so, I think it's worth trying out. Let's see how inflammable this stuff really is. Gosh, inflammable is such a stupid word. Well, that's a cool looking...
It really is. That's one of the things that baffles me about the English language, how flammable is like a piece of paper, inflammable means it's going to explode, and non-flammable means it's not going to burn. Kind of like valuable and invaluable meaning even more valuable. It's just a weird thing that's always kind of bothered me too.
Is it actually cold though? Let's try lighting some paper on fire with it.
Yeah.
Okay, so it's not that cold, but it does take a while for it to catch on fire, so that is pretty nifty. Now check this out. If I dip the paper in the burning liquid, the part that comes in contact with the liquid doesn't actually burn.
Is it cold?
That's because only half of this mix combusts in the flame, and that's the carbon disulfide. The tetrachloride actually poisons the fuel and absorbs a substantial amount of heat as it evaporates. This protects whatever surface the mix is burning on. In fact, this is why carbon tetrachloride was used in fire extinguishers before they figured out it was cancer juice. Ignoring the huge health risks
just like lead in
this stuff probably could be put on gasoline and lit on fire without causing burns. As tempting as it is, though, even I'm not dumb enough to try it. Like seriously, every single part about this is stupidly toxic. There's actually another cold fire
this guy's
just below it in this book. Although not quite as dramatic, it's one popular among chemistry teachers and has the added benefit of not inducing cancer in the audience. I like to add a pinch of baking soda to the mix to make the flame bright yellow. If you're like most people and stare at screens all day, there's a good chance you've dealt with dry and irritated eyes at some point.
Salves?
So what's the solution? Mercury salts and opium applied directly to your eyeballs. If that doesn't make your eyes feel better, I don't know what will.
Dude, no.
I've always been looking for a method of hardening copper. And check it out. Most of what I need is just pee. This is another one of those formulas where I'm not quite certain what the function of the ingredients is. I'd bet the hardening here is just due to the quenching.
Yeah.
The chemicals probably just clean and passivate the surface.
I guess it sterilizes it, sure.
Here we go. That smells amazing. Okay, so is the copper actually harder now? Let me give these a good scraping here. Okay, yeah, I think the treated one is a little bit harder. It doesn't scratch as deep, at least. I'm curious how the structure changed, so I'm betting an untreated one as a control. Now for the treated one. Huh, it feels stiffer, but it's actually easier to fold. Interesting.
Yeah.
No parade is complete without purple flames and mercury fumes, and this torch has them both. Look at that, 10% calomel. So calomel is mostly just mercury, so burning this at a parade is just going to fumigate the entire audience. However, it probably does make a gorgeous purple flame, so I'm kind of tempted to try it out anyway. I couldn't justify spraying.
Does he have a live audience there? I don't know.
So I swapped out the calomel with chlorinated rubber. The fumes are still going to be awful. At least it's not mercury, I guess. Well, here goes nothing.
That's cool looking.
Oh wow, that's incredible.
Wow.
That's the most purple thing I've ever seen in my life. Amazing. It looks like the mercury wasn't needed after all. Just a source of chlorine to deepen the flame colors.
See,
This book is very generous with its use of cyanide. Whether you need to clean some coins or
just regular chemistry, you can make a bunch of just cool glowy things. You don't need a nuclear reactor to make a cool blue Cherenkov glow. You get the green glowy uranium from apparently just this guy's chemistry set. I've never worked with green glowy uranium. It's interesting that I'm learning this sort of stuff. I like it.
Your engine running smoothly, they always find a way to throw some cyanide in the mix. Now, lucky for us, they also include this convenient
Speed is
procedure for
essential
dealing with your
with
inevitable
2
cyanide
exclamation
poisoning.
points.
The first steps aren't anything crazy, but check out step 4. That's one of the best sentences I've ever read. If patient survives, give a medic, and after vomiting, supportive of strong coffee with brandy or whiskey. Let's party.
Can you imagine if I saw that like in a procedural step at a nuclear plant that says if something survives, it's, man. I like that it's if patient survives. Like, that isn't the normal path when doing this sort of thing, that you expect it to be lethal. Wow.
Survived. Don't you hate it how easy it is to ruin furniture by spilling acid on it? Well, thankfully, this can be a thing of the past with this acid-proofing concoction. I love how making acid-proof wood involves pouring boiling acid on it.
I mean,
what doesn't kill you makes you stronger, right? The coats
you don't want
to
to pour caustic on it.
Didn't do anything crazy, but things got interesting with the second one. The wood started changing color, and dipping the paintbrush back into the solution caused it to change color as well. After the wood dried, it became much darker, and the second coating made it turn black. The chemistry here is a polymerization reaction that produces a polyaniline compound. These compounds are both acid-resistant and potent dyes. By some crazy coincidence, a chemist friend of mine stumbled upon this very recipe in a publication from 1925 on building a low-cost chemistry teaching lab. Okay, so is it actually acid-proof? Let's dump some concentrated hydrochloric acid on there and find out.
There you go, you can compare.
Huh, it really didn't do much to either of them. Interesting. Let's try something much nastier this time. Sulfuric acid tends to chew up most organic stuff it encounters because it's a potent dehydrating agent. Yeah, it looks like it chewed up the untreated stuff at least. Let's drop the base and investigate.
Drop the base?
The surface of the untreated stuff has been turned into a gummy mess. The treated piece has been affected too, though. It's not pitted nearly as badly, but some of the treatment does rub off. I'm not sure how much of it is the linseed oil versus the wooden polyaniline. Either way, it's not acid-proof, but it is acid-resistant, and it's certainly an interesting formula. This one's from the alloy section. It's an alloy that's apparently useful in making electrical fuses. Now, I'm not exactly one to fuse my electronics, but check out that melting point. This stuff should be able to melt in hot water, which I think is pretty impressive for such easy-to-find metals. I'll definitely be trying this one out. I started by melting the lead and bismuth together. Then once that was molten, I mixed in the tin shot. Unfortunately, I had a small incident which required me to melt it all back down again before casting it into cute little coin-sized pieces. So does it melt in hot water? One way to find out. Any second now. Okay, the water is clearly boiling at this point and the metal is still solid. What's going on? It looks like the book lied to me.
One way to test your melting point.
Turns out that no mix of these three metals can have a melting point of 168 Fahrenheit. Well, that's disappointing, but maybe it still works as a fuse. I'll take that as a yes. This one looks pretty simple. It's a remedy for sneezing. I mean, you can't sneeze if you're unconscious, right?
Chloroform?
Okay, this one's called toilet milk. What is toilet milk? I looked it up on Google and I couldn't find any meaningful answers. I guess I'm just going to have to make some of this stuff and see what it does. I figured this was supposed to be an emulsion of some sort, so I started by dissolving the cetyl alcohol in the oil, then added glycerin after that. As for the soap, I threw in a little lard soap solution, and also added a bit of freshly diced bar soap for good measure. I added the water, but the compounds really didn't want to mix at this point,
with machete.
so I tossed the whole thing in the microwave for a few minutes. And after shaking, the mix was nice and uniform. Well, I still don't know what this stuff is. Oh yeah, I forgot the perfume. Okay, now it makes sense. This is clearly some kind of highly moisturizing soap, which means only one thing. It's obviously for nourishing your toilet. I can't think of a better mix for cleaning and lubricating those pipes. Drink up, Nessie. Now, before I end this video, I feel like I owe it to the editors to clarify some stuff. It may seem like all the recipes in these old books are just insane, but I'm focusing on the craziest recipes here. In reality, these books were an incredible resource for their day, and not just for chemists either. You'll have all kinds of formulas for all different industries all in a single place.
They didn't have the internet
if you look
back
at the
then.
inventories for some old libraries, you'll find that some of them still have like 100 copies on hand, just because they were so popular back then.
Oh, that stuff was fascinating, and this guy, again, hopefully he has a good safety record, but just seeing the sort of stuff that he does seems a little out there. But I like looking at those old-timey chemistry stuff, and hey, seeing uranium used in a way that I've never seen it before. Uranium crayons. Just hope those aren't the sort of crayons that you eat. Let me know if you want to see me react to more videos like this with the more. I think this is the first time I've done one reacting to one of these extreme hobbyists of sorts where they do these little experiments. But I liked it. Thank you very much for watching. I'll see you next time.